All right, so welcome to a Finch Robot 2.0 playground. This is probably the last one of the year. I'm Tom Lowers. I'm the founder and CEO of BirdBrain Technologies, which is a small company in Pittsburgh, Pennsylvania, devoted to inspiring deep and joyful learning for all students through creative robotics. Creative robotics like what you'll be playing with today. And I'm joined on the call by Aparna Brown, our Director of Operations. Aparna, do you want to say hi?
Hello, welcome everybody. Thank you for joining us from all around the country and all around the world. Thank you, Luca, for joining us so late. We're really happy that you're all here and really excited to show you the Finch robot. Like we were saying earlier with Angela, whether you're teaching kindergarten students or you're in college and learning computer science, we really feel like this is a tool to learn computer science creatively for all learners. So we're really excited and appreciate you joining us. Thanks so much.
All right, thanks, Aparna. So today we're going to be doing two things. I'm going to give a brief overview of the Finch robot and where it came from and what the new version of the robot can do. And then you will actually get to play with the robot using remote robots technology. So that means that you'll be able to program the robots. I have 6 of them here in the studio. You'll be able to program these in a block-based environment, very similar to one of the ones that you could use in a classroom, in person with the robots. This particular environment that you'll be using is appropriate for roughly 4th grade up through high school, but we have many other programming environments for the Finch as well. So let me just quickly talk a little bit about the Finch. So here's kind of the link to the slides. Here's my outline that I just went through. So the Finch actually was initially developed at Carnegie Mellon University way back in the late 2000s. And it was developed to be an engaging tool for computer science education at that point at the high school and college level. Because if you remember 2008, 2009, it's not like many people were talking about computer science or coding at the elementary or middle school level. It was launched, the Finch 1 was launched as a commercial product in 2011. And I think okay, I'll deal with that later. Was launched as a commercial product in 2011. And as kind of the decade progressed, we saw more and more interest in coding for younger students. And so we developed some ways to program the Finch 1 in things like Scratch and things like Snap with blocks-based coding. But it became pretty obvious, towards the end of the last decade, or this decade, I should say, that, there's just so much new hardware capability out there. There's so many things that we could do that we could imagine if we updated the hardware or made a new Finch. And we also had lots and lots of feedback from teachers and students using the Finch 1s in classrooms. And so we were able to take all of that feedback and all of the things that have happened in technology in the last 10 years and use it to create the Finch Robot 2.0. It has the same mission as the Finch 1. It's all about learning computer science and computational thinking and to be an engaging tool. And now really designing that to work from kindergarten all the way through college. And so the way that we do that is by making it programmable in many different environments. So I'm going to do a quick run through of those environments. So here are kind of 2 different ways to program the Finch. One is with Finch Blocks, which is a tablet app that we developed for both Kindle Fire tablets, Android tablets, and iPads that is appropriate for kindergarten to 3rd grade. And that code just makes the robot go forward and backwards. Below that is some standard Java code for controlling the Finch, and it moves it forwards and then backwards. So essentially the same behavior is being created by these 2 very different programming environments. So that really reflects the kind of low floor, high ceiling approach that we took when developing the Finch. So just to give you a brief overview of all the different programming environments, on tablets and phones, you can use Finch Blocks, again, for kindergarten to 3rd grade. Finch Blocks itself actually has 3 levels within it so that, as students grow, they can start with level 2 or level 3, which lets you use parameters. Level 3 even lets you use sensors. Once they kind of graduate out of Finch blocks, we imagine them moving into bird blocks, which is appropriate for 3rd to 8th grade, again, on tablets and phones. It's a very Scratch-like environment, using this sort of puzzle blocks analogy of Scratch, to allow students to create more complex programs than they could with Finch blocks, but to still do it on a tablet. Once you go over to Chromebooks or computers, we have support in Snap, which is a programming environment that was originally kind of inspired by Scratch. So this is very much like Scratch programming. And we also support MakeCode, which is the environment that is used by the BBC Microbit. It's a blocks-based environment, but what's really cool about MakeCode is you can click a switch and see the code in text. So you can see it in Python syntax or JavaScript syntax. And then you can even make changes in Python or JavaScript and then switch back into MakeCode into the blocks environment to see what changes that created. So it's really great for students who are right at that transition point where they're getting ready for text programming. And then again, at the high school level or the college level, you can program these in Python, you can program them in Java, so they'll work in an APCSA or an APCS principles or an introductory college class. We've even developed a 3D printable smartphone mount, which I have my phone mounted to right now. And that, coupled with a library or API of that's written in Swift or Kotlin, allows students to create their own apps that control the Finch. So once you add a smartphone, now at the college level or advanced high school level, you can be asking students to do computer vision with the Finch, AI with the Finch, natural language processing with the Finch. So really trying to hit kind of every age group. In terms of the hardware, in terms of the outputs of the robot, obviously it drives around, it has wheels. The wheels have encoders, which means that you can command the robot to move 20 centimeters, turn 90 degrees. They can do those movements accurately, so it can draw shapes. It has a central pen mount, so you can put a marker in it to actually make some drawings. It has lots of LEDs. It has an LED in the beak, like the original Finch. It has 4 LEDs near the tail that are full color LEDs that are individually addressable. And then it has 25 LEDs, kind of a 5x5 array that's in the microbit in the Finch's tail. And that's good for making characters or making emojis on the Finch, so giving it a little extra personality. It also has a buzzer, multi-tonal buzzer, so you can make different sounds, maybe 8-bit like video game music, basically. In terms of and it has a plastic brick adapter, so you can put your favorite plastic bricks on top and build structures on top of it. So maybe, personalize it a little bit. In terms of the inputs, in addition to the wheel encoders, it has a distance sensor in the front, 2 light sensors, so it can track a light beam, 2 line sensors, so it can follow a line on the floor, and then a compass, so you can actually program these to always drive north or always drive west, an accelerometer, which allows the Finch to detect its orientation in space, so you could pick it up, point it with its beak down, and it would know that its beak is down and maybe plays different musical notes depending on how you've oriented it. And then it has 2 buttons on the microbit as well. So I've mentioned the microbit a couple times. The microbit is a wonderful tool for physical computing education. We've at BirdBrain Technologies have built all of our new products around it because it is really very, very capable at a low price point. And so by designing around it, we didn't have to reinvent kind of all of the things that the microbit provides, things like the accelerometer, the 5x5 LED array, Bluetooth capability, and MakeCode. We could just kind of use that and build around it. And so if you have microbits, that actually makes the robot slightly less expensive also, because you can purchase a version without the microbit included. We really thought about the durability of these and the battery life. So It's supposed to last for a full classroom day. It lasts for 7 hours with all motors going and all LED lights on. So it actually lasts more like 15, 20 hours if you're thinking about it from a normal use perspective. And I see one of the robots has started moving. That's great. So it also comes with a ton of activities, coding tutorials, and professional development courses. So when we think about our products at BirdBrain, we don't think just about the hardware or the software. We are trying to create learning experiences, and we want to make sure that that you are successful in doing so, right? In making the most effective, most engaging learning experiences possible. And so we provide free professional development on how to program these in blocks languages. We'll hopefully be adding Python to that next year. We provide some activities that you can do with your students. We provide coding tutorials that are very step-by-step that your students can follow or that you can follow with your students. And they are all free, and they're all available on our website and live now. So here's an example of just a link to our learning materials for Snap. Snap is the language that is most like, or the programming environment most like what you'll be using to program the remote robots today. So that's the Finch. And the other thing that you're going to be using today that's kind of new is this idea of remote robots. So we developed this at BirdBrain right around when the pandemic first hit, so in March and April. And the idea of it is, instead of providing a simulator, let's make a way for you to be able to program the robots, real robots, over the internet, and then view them via video chat or live stream. So how do I get, my nephew in Belgium to program my robot? It's through remote robots. And it's really pretty magical. I mean, the way it works is we will send you a link that opens a project where you can control the robots. You can click on blocks in that project that move the Finch or turn on its LEDs or whatever. And that gets sent over the internet to a project that I'm running here locally in the studio that controls or sends commands over Bluetooth to the Finch. And so I can actually connect 3 Finches to a single computer using this system. And so I have 2 computers in the studio for the 6 Finches that we have. This is something that works with our other product, with the Hummingbird Kit. And it is also something that we've documented and are now seeing teachers actually using. So we've seen quite a few teachers start putting these out there where students program robots that they have set up from just remotely or over video chat. And it's pretty cool to see. The other thing that's neat about this is you can also take sensor data from the robot and send that over Bluetooth. And then that gets sent over the internet back to your project. So you're actually able to read the sensors on these robots, like their distance sensor, their light sensor. So what that really means is that you have you've turned this robot into an Internet of Things object. And so kind of a tangent, but if you ever need to talk about Internet of Things, this is a great example of an Internet of Things object because it's something that is controllable over the internet with both outputs, you're controlling the motion of the robot, as well as sensor data coming back to you. All right, so let's get started with how to actually program these robots. So Aparna will put this link in the chat, and I'm going to take you to it as well. So this is a special web page that just has some instructions for how to program the robots. There's a link to the Finches. When you click on that link, it opens a project in something called NetsBlocks. NetsBlocks is the programming environment that is based on Snap, but that adds networking, and that's what makes the magic of remote robots possible, essentially. So I've opened this project. You all can open a project, the same project on your ends. There's no concern about those projects interfering with one another. Basically, when I click this link, it's like it opens a brand new project like makes a copy of the project essentially. So when I make changes on my end, you're not going to make changes on your end, or you're not going to see those changes on your end. So once I have this open, I can connect to the robots, and let me just make this a little bigger so you can see it more clearly. There we go. So there's a set of blocks here that say when the C key is pressed, connect to any robot. I'm going to click on that, and it's going to tell me I'm trying to connect to Finch A, trying to connect to Finch B. Okay, Finch B is the one I got connected to. It says which Finch B. Now, if I want to move the robot, there's a little sample program with a green flag. So I can click the green flag or even just click on this set of blocks. And now that is actually moving Finch B. And you can see it moving with the Finch point of view camera. There we go. I can also click on individual blocks and see what they do. So I can make its beak green and its tail green. I can make it beep. I can check the distance sensor. It's reporting, 14 centimeters right now. I can change this program, in real time. I can stop it. So as long as I'm connected, basically, this is live coding. Everything I do, just like in Scratch, you will see it pretty immediately via the video chat. When you are kind of done for a moment, you can disconnect from the robot by pressing the X key or this set of blocks. Now I'm disconnected. Somebody else can play with robot B. But even though I'm disconnected, I can continue making changes to my code. I can think about a new program that I might want to make and create it down here. And then I can press C again to reconnect and program the robot again. And so since we have, I think, slightly more participants than we do robots, I would ask that, while you're programming, if you're really thinking through what you want to do and, your robot isn't going to move for a few minutes, disconnect so that somebody else can have a chance. And then when you're ready to try, hit C to reconnect. The last things I wanted to say about this environment in particular is where the blocks are. So the Finch blocks in particular are always going to be down at the bottom of the category. So at the bottom of the motion category, you'll find blocks to move the Finch. At the bottom of the looks category, you'll find blocks to move, to light up the beak or tail LEDs. At the bottom of sounds, you'll find the Finch play note. And at the bottom of sensing, you'll find the Finch sensors. The rest of the blocks are actually used for animations and games, just like in Scratch. So the top motion block, this move 10 steps, that actually moves the sprite in the canvas, in the white canvas area. It turns it also. So yeah, let's go back to this page. So that's kind of a quick orientation of how to use it. There's some suggested activities that you might want to look at to try. There's a description of all the snap blocks. Again, technically we're using nets blocks, but it's essentially the same thing for the purposes of programming the Finch. So the snap blocks, and then there's some tutorials for how to move, how to set the LEDs, how to use the sensors. And I believe that's pretty much it. I wanted to give a quick overview of Zoom here. So I'm going to switch to a top-down view for my main view. And so you can use this to kind of see where your robot is. You can see which one it is. So D, C, D, they're all labeled. There's two other views in the studio that you can look at. There's the Finch point of view, so Finch POV. That's my phone, which is attached to robot F. So that's a fun one to kind of look at and play with. And then there's a view called Tom Lowers, and that's kind of a side view coming at it from the laptop that I have set up here. So you can also look at that. So when you're programming, I recommend going into speaker view in Zoom so that you can see kind of the main views, and then you can double click on any view that you want to pin or keep in your frame while you're programming. And that's it. I think we are here to help, to answer questions. You can ask them, verbally, or you can ask them in the chat. We'll do our best to answer them mostly verbally, and otherwise just go ahead and program and get started. I'll spread them apart a little bit. A lot of my job at this point becomes just robot management, keeping them okay.
And people
Oh, right. I think half my robots turned off because my laptop went to sleep. So I'm just going to fix that. So A, B, and C are definitely working. D, E, and F, give me 2 minutes to turn them back on.
And feel free to ask questions in the chat or unmute yourself about either programming the robots in the studio, remote robots, how to build your own remote robot, or anything about the Finch. So if you're interested in one of the languages for a particular age group, or interested about how to integrate it into the classroom, anything at all, we're here to answer any questions you have.
Okay, I see D, E, and F all connected really fast. Yeah, it looks like all the robots are currently in use. So that should be fine for right now. We have the right number of participants for that. Okay, C is available. So got one that's good. How is this type of technology used in real life? That's a great question. So, I mean, robotics more generally is used in many, many different places, right? I would say the Finch robot in particular is meant primarily as a teaching tool. Sorry. So it's meant as a way for students to learn both computer science and robotics. So learn some of the things that are specific to a robot, like the fact that you have sensors, that you have outputs that you need to control, and that you take the sensor data and use it to create behaviors. On the computer science side, you're trying to teach concepts like variables, control structures, data, and those concepts really are applicable to both, physical robots, but also to agents, which are virtual robots, so artificial intelligences, and also to just general computer science. I wouldn't expect anyone to use the Finch specifically for a non-teaching application, I guess. So that's not really what it's for, but certainly if you use the Finch, you'll have a better understanding of how many of the things that are out there work, how many robotic, many different types of robotic systems work. Robotics in general is used in, definitely has military applications. So perhaps unfortunately, but most modern technology has military applications. The most common place where you see that is with drones. So those are, essentially robotic aircraft that can be used for many applications, including military applications. Yeah, remote package delivery is a good example of both. I mean, I know that there's like attempts to use drones to deliver lightweight packages to people. And then there are also, there's a whole lot of research into autonomous cars and trucks, which would get you, most of the way to delivering a package. And then there's research into walking robots. So you could even imagine at some point, I'd say this is probably 20 years off, but a remote truck, a remotely operated or an autonomous truck pulls up to your house, and then a walking robot unloads the package and puts it on your front porch. Again, that technology is probably about 20 years off from really being reality. I think a lot of people in robotics and also just a lot of engineers tend to be overly optimistic with timelines, but that doesn't mean it's not coming. It just usually takes a little longer than you might hear from the science journalists. So Brianna's asking about using the robots remotely, and do teachers usually only have one robot? We've seen a variety of setups. Since the Finch 2 is only shipping now, like essentially starting today, most of the other setups have been with the Hummingbird robotics kit. And with those, I've seen typically like 3 robots to 1 computer. So often I see 3 robots. I talked to a teacher earlier this year, well, just a month ago, who has set up 12 robots. It was like, wow. And he told me in September that he was going to do this. And in November, he'd done it. He'd set up 12 robots, 4 laptops, webcams pointed at like 1 webcam for every 3 robots. And he was working with something like 600 students. So he was really trying to like leave it on all the time so that there was not an access problem. So yeah, it's pretty crazy. Like at some of the larger schools, they really are trying to scale it.
And we actually have an expert on the call, a teacher who started using remote hummingbirds first thing in the spring. So she was the first teacher that we know of who used them. So Erin's on there. I don't know if she's in a spot where she can unmute, but she can definitely weigh in on her experiences using remote robots, being the pioneer.
Thanks, Aparna. Yeah, I used the Hummingbird bit robots back in the spring and had a setup of 3 robots, kind of what Tom was describing. So I had 9 students, 3 robots, so it was 3 kids per robot, and had them sort of kind of create a design, and then I went through my recycling bin and created their design. And so when we met for class, they were using this, basically the same setup we're doing now, except for instead of the Finch, we were using the Hummingbird bit kits for them to program. So it was a learning experience for everyone, but it was a lot of fun in figuring it all out.
Yeah. So one thing that's different about the Finch versus the Hummingbird with respect to remote robots is the Finches work really well in this sort of synchronous setup. But since they're mobile robots, you kind of have to pen them in. And so it's harder to imagine a situation where you just leave the robot running for 12 hours with a camera pointed at it, because you don't know if they'll, somebody will drive it into the wall for 30 minutes, things like that, that are a little harder to control. The Hummingbird kit is a kit of parts that you build kind of cardboard robots with. And in many cases, you can build those robots to be stationary. So animatronics, things like that. Imagine or think about like the stuff you see at Disney World in terms of those types of animatronics. You can make those kinds of things with Hummingbird. So it's a little bit easier for the more asynchronous use case where you want to have them running for a long period of time and just let people program. In fact, we have, Aparna just put in the chat a set of 5 robots that I have at my house that are on on 24/7 live streams that you can program anytime. So if you like doing this and you want to send that to your students, or you want to play with them yourselves, they're available. I try to check that they're working. I'd say they're working about 95% of the time, but sometimes Windows decides to update the computer, and sometimes there's a thunderstorm in Pittsburgh. Like there's some things that I can't quite work around. I do like it. Two of those robots, the dragon and the gnome, are in my office. So whenever they start moving around, I kind of smile if I'm there. I'm like, hey, somebody's programming the robot.
Can I ask a quick question?
Yeah.
So I'm trying to use the sensors, and it seems like every time I try and use a sensor, it works initially, and then it sort of stops. Like the one that's going in circles right now is going in circles right now because I can't get it to do anything else.
Huh.
Have you had any issues with the sensors?
I haven't seen that, but I think in these playgrounds, people don't use the sensors as much.
Yeah.
So it could just be not as tested. Which sensor were you trying to use specifically?
I was using the distance sensor.
Okay.
And I had it going so that when it was less than 10 centimeters, it was supposed to turn right 90 degrees. And it did it the first time, but now it's just, or maybe it was left 90 degrees. But either way, it was just like going around and around and around in circles after it did that initial test.
Let me try that on one of the other robots, maybe. And do you want, like, are you able to disconnect from B or?
Yeah, because usually what I have to do is I disconnect.
Yep. Okay.
And it stops. Yeah. And then I reconnect, and it usually works again one time, and then it stops working after the one time.
Is it in a
forever loop? Yeah,
code?
It's in a forever loop.
Let me try that for a second. I'll connect to B and see if I can replicate the problem. Or if you could, if you can do export project from the file menu and send the project or email it to me.
Yeah, I can do that.
That way I can also take a look at it later. But for now, let me try to connect here.
Yeah.
See if I can use a sensor. So Finch distance seems to be updating. Yeah, and I even have that little like forever loop set up.
Well, yeah, that's what I used. I sort of just took that and adjusted some of the settings.
Okay. Well, that's working. Okay. No, it's working for me.
Yours is working. Okay.
Yeah. So it really is only one time for sure that it doesn't work for you.
Yeah.
Huh. I can share my screen real quick. just so people can see that code. You know, might be interesting just generally. I'll disconnect for now. Make this bigger.
And Tom, we've got a question about someone trying to connect to the Hummingbird remote robots in your office.
Okay.
And it seems like they're unable to connect and wanted to know if it gives them an error message.
So there is like a 15-second delay, but if it's not connecting at all, then like if there's no message popping up, then yeah, maybe it's possible that one of those two has gone off. So I would then try the, so the dragon and the gnome, if that laptop went down for some reason, you know, that's one laptop controlling those two. So go back to the remote robots page and try the Twonky and LB or the city skyline.
I do see a check mark next to all of them. I don't know where the dragon's check mark is, but all the other ones, the microbit. Oh, there we go.
Yeah.
The dragon is going now, so.
Okay. Yeah, so there is so the problem with like a live stream like that is that there's a 15-second delay between when you connect and when you see things and when it actually happens, or when you actually see it on the video. Whereas with Zoom or with video chat, it's synchronous, and so you see things happen much faster. All right, so just to quickly show people, this is the code that I'm running. That's kind of controlling the Finch and having it kind of turn when there is an obstacle and go straight when there isn't an obstacle. So I will go back to the overhead view so you can see that a little more too. Oh. And of course, if I don't have the browser window up, it doesn't run my project, so. Okay. So I'll disconnect from this robot now.
And Tom, we've got another question from Luca. He asks, let's say you get mad at people for using the remote robots in your office. How can you stop them from playing with it apart from disconnecting with the power button?
Well, so I have on the robots in the office, there's a 20-minute timeout. So I can, you know, at worst, they're going to play with them for 20 minutes. But there isn't really a way for me to turn those off remotely. So I can't go over, like, I can't turn it off from here. I'm not at my house. I would have to be at my house in order to turn it off. I don't have to unplug it. I can just stop running the code, but I do have to be at the laptop there in order to do that. I mean, there are ways to create, you know, remote desktop solutions. So I could try to set up a remote desktop for that laptop, but frankly, there's a pandemic here and I've been home a lot, so I haven't felt the need to do that. And so good question about saving work. So there are two ways that you can save projects in Snap or NetsBlocks. One is to create a cloud account, and you do that by clicking on the cloud icon in the top left. The other way is to click on the little file icon that's to the left of the cloud icon, and then you can export your project, and that'll create an XML file that you can save to your, save to your computer. So yeah, those are kind of the two ways of saving. There's a third way that I don't recommend, but I guess I'll mention it. You can save to your local browser cache also, but the reason I don't recommend that is if you do that in many schools, computers are set up by IT in ways where the cache either, it's not a permanent thing. It might actually reset once a day, or students go to a different computer, whatever. So it doesn't seem very safe. to save to the cache. Okay, so collaboration. Synchronous collaboration, like Google Docs style collaboration, is possible with NetsBlocks, but what I looked into this because I kind of obviously wanted people to be able to do this, but it's possible, but then you are unable to connect to the robots at the same time. So you would have to be collaborating, and then you would have to have one person disconnect, and then you can connect to the robot and actually make it go. And the process for doing that is something like 6 or 7 steps, so I don't recommend it. What they can do is they can collaborate asynchronously. So they could either have the same cloud account and one person could work in the file while the other person perhaps looks on, or uses a screen share on video chat, or you share XML files. You save the XML file, you send it to the person you're collaborating with, they edit it, they export it, they send it back. Yeah. I think, yeah, so that you can definitely do that.
I wanted to see, I put in the pen down and I wanted to see if like the robot could draw. I did a little program for that. I don't know if.
Oh, okay. So the pen, that is confusing. The pen they're referring to is the pen on the sprites. Like,
Okay.
if you were to move that little sprite, it would now draw a line. For the Finch robot, there's not a pen up, pen down mechanism. So I can put a pen in one of these. I don't know which robot you're connected to, but I can.
I was trying to connect to D. I think I might be doing something wrong though. I don't know.
Okay, let me open D back up because I haven't seen. In fact, I'm gonna open up D, E, and F. Just reset them real quick.
Let's see.
If you were connected, you can always reconnect. Okay, so those are all available now. So let me know which one you get connected to.
In the when block, should I check D for the robot, or should I have C in there and then just press D on my computer keyboard?
You can do any, so that's the default, and it'll connect to the first available, or you can put the letter D in capitals in there, and then you would press C on the keyboard to connect to it.
Okay. So if I just keep C as the default, but I want to move robot D, I can just press D on my computer keyboard?
No, so to do it, let me switch back to the code. Sorry. Okay, so here you'd want to put connect to robot D, and then you could either click on this set of blocks or you would press the C key to activate it.
All right. Okay, thanks. So when C is pressed, connect to robot D.
Yeah.
C is pressed. Oh, okay. Nice.
And Tom, Ira has put another question in the chat. If a student completes a project and wants to submit it for feedback or a grade, would they send their teacher a link or a file within their Snap account?
So they could export the project. They can also publish it and send a link. So they can do either one. So they could either export the project and send the teacher an XML file that you could then import, or you can hit publish on these in the save menu. There's a publish button, and then you could send the link to them. Okay, no one is connected to Robot D yet, so let me know when you connect. When you publish, it become like you need a cloud account in order to publish, but the form is going to be a link, a shareable link that anyone can view.
Okay, I'm still doing something wrong because D isn't moving.
Yeah, I see that. In the canvas, the white area on the right of the screen, do you see a which Finch? Does it tell you something there? Or does it say none?
It says C, which Finch C, connected, true.
So you're actually connected to Finch C then,
Okay,
which is connected. So I'll in fact, I'll put the pen in Finch C and then see if you can just click the green flag or see if you can get it to move.
okay, just curious, so, but with the blocks that I have in the workspace, it says, when C key is pressed, connect to robot D. So why in the stage is it connecting to which Finch?
I think you were already connected to robot C.
Okay,
And so it doesn't let you connect to more than one robot at a time.
okay.
So that's probably why. And we've got about 2 or 3 minutes of programming time left. So I just wanted to give that warning. So if there's something you want to try it now. And then we'll do a quick wrap up.
Know why it's moving. I think you put like a red pen in there.
I did, yeah.
It's not, and all I have to do is hit the green flag.
Should be if the original code is still there, or take a Finch move. Take a Finch move block from the motion category and just click it. See if that will make it move. So make sure you're not using like a move 10 steps, but make sure you're using one of the blocks at the bottom of the motion category, like Finch move 10 centimeters. Let me see. All righty, I'm going to switch back to the slides. Just wanted to say a couple of last things. So thanks for trying this out with us today, programming some robots and trying out the Finches and learning about them. If you'd like to request a demo of either a Finch 2 robot or a Hummingbird kit, we can make that possible. Just click on that link and we have the ability to provide 60-day demos of those products. And then we have our slides again linked here. So yeah, does anybody have any last questions or thoughts?
Thank you so much for joining us today. We can't wait to see what you make on social media. On Twitter, Instagram, and Facebook, you can tag @BirdBrainTech or #HummingbirdKit, or you can even tag me. If you have any questions, be sure to email us, info@birdbraintechnologies.com. We can answer questions about purchasing, about learning, about teaching, and about professional development. If you haven't been there yet, be sure to visit our Robotics at Home page. There you can purchase a kit for yourself, learn how to use it, and even join one of our upcoming webinars. Until we see you in class, thanks for watching from everyone at BirdBrain Technologies.